everyone, I am Erlyn Balontong of PS Entrepreneurship 2-2 and this is my report. One of the classes of the nutrients and their composition in animal nutrition was the fats. But what is fats? Fats or lipids are made up of 77% carbon, 12% hydrogen, and 11% oxygen. Insoluble in water but soluble in organic solvent. Insoluble means incapable on being dissolved. High energy materials supplying 2.25 more energy than carbohydrates and proteins. Fats are the slowest source of energy, but the more or most energy efficient form of food. These fats used to denote lipid that is solid, while oil that which is liquid at room temperature. In this animal nutrition, there have four functions of fats. First was the dietary supply. Fats become dietary supply because it serves as the excellent source of energy and essential for the survival of the animals. Then, because fats is located beneath the skin, it serves as source of heat, help the insulation to keep the body warm, and serve as the protection of the animal body. The next was fats also source of essential fatty acid and serve as the carrier for absorption of fat-soluble vitamins. There are some vitamins that the animals intake that can dissolve in the water, so those vitamins will remain through the fats. The next one was the deficiency and abnormal. Where do we locate or where do we distinguish where was the fats? In terms of animal body, there have three. First is subcutaneous, located under the skin of animals and accounts for the largest amount of fats in the pork carcass. The next one is fats surrounding an internal organ of the animal body. And the next one is the marbling and milk. This marbling was appears in delicate pattern of the wavy lines in the meat. In terms of natural resources, we can find those fats most of the feed that have less than 10% fat except oilseed of 20%. The next one was the classification of the lipids. We have three classification of lipids. First one is the simple lipids. Ester fatty acid with various alcohol. In Wikipedia, ester means chemical compound derived from an acid, organic or inorganic. There have two types of simple lipids. First was the neutral fats and oil. Example of this is triglycerides. When we say triglyceride, it means 3 ester fatty acid with glycerol. When we have 1 ester fatty acid with glycerol, we called it monoglycerides. When we have 2 ester fatty acid with glycerol, we called it triglycerides. These neutral fats and oil, they are uncharged and do not contain acidic or basic groups. The next one was the waxes. Ester of fatty acid with monohydroxyl aliphatic alcohol higher than glycerol. These waxes are found in nature as coating on leaves and stems. These waxes prevent the plant from losing excessive amounts of water. So these waxes also serve as protection for the plants from too much amount of water. The next classification was the compound or complex lipid. Ester of fatty acid with alcohol plus the presence of other functional groups such as phosphate, nitrogenous bases, proteins, and carbohydrates, etc. In compound and complex lipid, we have three. First one was the phospholipids. In the picture show, there have hydrophilic head and hydrophobic tail within the phospholipid. This phospholipid was containing a phosphoric acid residue in most cases in nitrogenous bases. Group of polar lipids that consists of two fatty acid and glycerol unit and phosphate group which is esterified to organic molecule such as choline, ethanolamine, and N-acetyl. The next one was the glycolipids. Contains of spiconizine as a structural backbone fatty acid and carbohydrates. This is a lipids with carbohydrate attached with glycosidic bond. As the picture shows, there have sugar residue and lipid residue, and there have glycolipid on the top of the lipid membrane. The next one was the lipoprotein, a group of polar and non-polar lipid associated with apoproteins. In the picture shown, there have lipoprotein consists of triglycerides, protein, phospholipids, free cholesterol, and cholesterol bound to fatty acid. Those I have stated was inside or within lipoprotein. The last one classification of lipids was the derived lipids, fatty acid that can originate from the simple and compound lipids by means of hydrolysis. Fatty acid, glycerol, and steroid derivatives was included in it. There have two types of derived lipids. First was the fatty acid. It's carboxyl acid with a long unbranched aliphatic tail or chain, which is either saturated or unsaturated. It is a building blocks of the fat in the bodies and the food we've been eat. As the picture showed, there have a carboxyl group and hydrocarbon chain. This picture show how the fatty acid structure. The next one was the esterol, our subgroup of steroids with hydroxyl group as the three position of a ring. Essential components of cell membrane where in conjunction with phospholipids they confer lipidity. We have three structure of fats. First, we have glycerol and fatty acid. Glycerol is an alcohol with 3 carbons. As the picture shows, there have 3 C at the middle, 5 hydrogen, 5 H at the top, and 3 hydroxyl, which is 3 OH at the bottom. Fatty acid have a long chain of hydrocarbons with a carboxyl group attached, maybe 4 to 36 carbon. However, most of them have 12 to 18 only. The next was the saturated fatty acid and unsaturated fatty acid. So, saturated means a simplest fatty acid that are unbranched linear chains of carbon groups linked by carbon-carbon single bonds. When we say single bonds, it was the only one line between C and C. As the picture showed, there have saturated fatty acid at the top and unsaturated at the bottom. We have through the process of the saturated fatty acid, it's only one line linear, so straight lang siya. Then single bound lang yung carbon and carbon, which is only one line between C and C. While unsaturated fatty acid have one or more carbon-carbon double bonds. So as you can see in unsaturated fatty acid, it's not linear compared to saturated na straight lang yung line. In unsaturated, may paliko na siya. And also, between dun sa paliko, between sa pa-curve, there have C and C, tapos 2 lines, which is we call double lines. Carbon-carbon double lines ang tawag po doon. In this classification of fatty acid according to the presence or absence of double bonds, we have 2, like what I said, saturated fatty acid and unsaturated fatty acid. So we have to differentiate each of them. First one, this saturated fatty acid have no double bonds. Like what I said before, straight lang siya. I mean, tig-isa lang talaga yung line niya. Double bond means a type of chemical bond which is 2 electron pairs are shared between 2 atoms. They may be short, medium, or long chain fatty acid. Solid at room temperature. Again, it was solid at room temperature. They are abundant in animal fats. They are named systematically after corresponding hydrocarbon with the same number. and always ends with anoic. There have some example here of saturated fatty acid from the common name to systematic name: capric, lauric, mysteric, and etc. The next one was the unsaturated fatty acid. So as I've been said before, it have one or more carbon double bonds. So between C and C, there have two lines which is double bonds. Hindi lang siya isa, minsan dumadalawa siya. And it always ends with enoic. It has long chain. Compared to saturated fatty acid, sometimes maybe short or medium, malimit lang yung long chain. But here in unsaturated fatty acid, always a long chain. And unsaturated was a liquid at room temperature. Again, when we say saturated, solid. Unsaturated, liquid. And there have some example of unsaturated fatty acid from its common name to systematic name. Lastly, we have here different tests used in fat quality. Iodine number. First was the iodine number. Determine the degree of unsaturation fat since iodine reacts with double bonds. High iodine number indicates presence of more double bonds. Measure for the unsaturated character of the fat and oil and used to prove its pureness and quality. The next one is the saponification value. Determined by reacting fat with alkalis such as potassium hydroxide and sodium hydroxide, thus forming soaps. They act as the carboxyl group of the fatty acid. The higher the saponification value, the shorter the chain length of the fatty acid. Saponification value refers to the amount base and required to acidificate a fat sample. And lastly was the melting point. The temperature when fat liquefies while solidifying point is temperature when oil solidifies. Melting point of a substance is the temperature at which it changes state from solid to liquid, and solid and liquid phase exist in equilibrium. This three was used to determine the test how to get the fat quality, how amount of fat does the animals. And that's all my report regarding to the fats as the one of the classes of nutrients and their composition in terms of animal nutrition in this chapter. And again, I am Erlyn Balontong reporting. Thank you.